Okay, it's day 2 of learning about stretching and shrinking. So this first one, pretty easy. We practiced it yesterday. I'd like to start with this one. So I'd like you to make an XY chart and try to find 5 points that would be on this graph. Typically, you take things that are around 0, so maybe you use -2, -1, 0, 1, and 2. Those 5 would be very logical. And let's have you put in those 5 and see what you get for the y values, graph it, and then let's see if you understand domain and range. And I'll talk it over with you in a minute. Then for this next one, I'd like to squeeze in on the inside here a little 1/3 so that we are multiplying whatever's in there by 1/3. Okay, so there's a 1/3 in front of that. So try these 2 questions. I'll give you a minute and let's see if you understand the basics. All right, when you put in -2, you should add the absolute value of -2, which is 2. And then the absolute value of -1, which was 1, and then 0, and then 1, and then 2. And as I graph it, it makes your classic V shape just like this. And I'm not going to draw my line through those points, otherwise it'll just kind of make them more messy. But there would be a line going through each of those points. Oh, what the heck, I'll put the line on there, but then I'll go back over it to show my distinct points, as we like to say. And there we go. Okay, now what's the domain? Remember, domain is this way. It's how far it goes in both of those directions, like this way. That's domain. And is this going forever in both directions? Yes, it is. -inf to positive infinity. If you were using a Schoology quiz, use INF. The range, how low to how high? And that was from 0 to infinity. Hope you're catching on to these. All right, domain and range. Oh, wait, we got to get the graph first. So I'm going to get an X and a Y chart. You're going to have picked some numbers, like let's say you pick 0, and 1/3 of 0 is still 0, and square root of 0 is 0. So 0, 0 is on my graph. What if I put in 1? Well, boy, you really got to be careful on this one because not many things are going to work. Because if I put a 1 in, then I got to do the square root of 1/3. Who even knows what that is? All right, next, I wouldn't even want to do 1, but you know what I would like to do? 3. I'm just being strategic because now I'll have a 3 right here, and 3 times 1/3 is 1, and the square root of 1 is 1. So 3 comma 1, over 3 up 1. All right, now I'm just kind of looking at what the graph looks like, and I know that what the square root of x looks like, but remember there's a 1/3 in front of this, right in here. So I know, just thinking, the square root feels like it should be horizontally shrunk, but it's actually a horizontal stretch. So it's like somebody grabbed my square root, which normally would have been here, and grabbed a hold of it, like let's just say this is your fingers and here's a thumb. They grab it and they pull that way, horizontally. Okay, and now we'll know what it looks like when I graph. Probably only one more point. All right, so do you get that it would be ideal if this area here was a 4? So let's be strategic. If I want that to be a 4, then x should be what? Think about it. If I want that to be a 4, x should be, if you know what it is, say it out loud. Prove to people that you know. It's 12, because 12 divided by 3 would give you 4. See, inside there we have a 1/3, and then we times it by 12. That's like 12 over 3, which is 4. Square root of 4 is 2. So 12 goes with 2. So boy, that was even off my graph, see? So here is my very stretched out square root graph. All right, how about its domain and range? Well, a domain doesn't go forever in both directions. Square roots, you can't put negative numbers in there. So the domain starts right here at 0, and it keeps going to the right though. So 0 to infinity. Brackets when you can touch something, and it can touch 0. And the range is how low to how high. The lowest it went, 0. Highest it went, infinity. All right, so there's a good review of your basics. Go to this page. Now, again, I'm warning you, I think kids that are addicted to somebody gives them the parent points are going to be really messed up in this next test because we will not be giving those. So what I suggest is you put in any numbers you want and just see what comes out. I'm going to put in 0. I'm going to put in 1. I'm going to put in maybe -1. Let's see what I get. I'll pause for a minute while you see if you can graph this all by yourself. All right, so I'm thinking when I put in a 0, I get 2 times 0 is 0. Absolute value of 0 is 0. And the next point is I put in a 1, and then it's 2. Absolute value 2 is 2. Then I put in a -1, and then I get -2 on the inside, but the absolute value of that is still 2. So if I were to graph this, I got 0, 0. I got over 1 and up 2. Over -1 and up 2. Well, look at that. It's a V shape. It'll go just like this. Does that make sense to you? Now, if I had asked you to describe it, you should have said high-vo, horizontal on the inside. That's a horizontal change. And it seems like it's twice as big horizontally, but it's actually half as big horizontally. You know what the original would have looked like? The original would have looked like that. Do you get horizontally? This thing got narrower. Okay. So let's go back to this one. And this one, just to make sure that you know what you're doing, I'm going to give you a few numbers to put in. No, actually, you should be able to do this one all by yourself. You pick the x's. You see what the graph looks like. I'm going to pause one last time. All right. Did you pick 0 for an x? That would have been smart. Square root of 0 is 0, and then you take half of that is still 0. Then let's try putting a 1 in there, because the square root of 1 works. Square root of 1 is 1. Half of that is 1/2. Remember to times by a half when you're done with the square root. Okay, now I'm going to put in a 4, because that's the next number that works nice. Square root of 4 is 2. Half of 2 is 1. Let's do one more number that works nice. Square root of, say it out loud. Don't be shy. You should have been a 9, because square root of 9 works out nice. Square root of 9 is 3. Half of 3 is 1.5. If you said 3 over 2, I'd be totally fine with that. Then you should have graphed them. 0, 0. Over 1, up 1/2. Over 4, up 1. So yeah, see how it's a square root graph, but it's really short. Like, why? Because it's got a 1/2 stretch in the front. That's not really a stretch then. It's a shrink. Half as tall as it used to be. And it used to go over 9 and up 3. That goes over 9 and up 1.5. So I'll draw my line through this thing. Okay. And there's my square root graph, except it got vertically shorter. Okay. I feel like if I do many more of these, that I won't be able to convince you to do any for homework. And so I feel like we've done enough that you probably are okay. At this point, the teacher could freeze this and do the problem on the board if he feels like you need more practice. If so, go ahead and do that. All right. So let's just talk through one last few slides here, and that is, what does this do? You'd think it makes it twice as wide, but it shrinks the x values makes them half as big. You're thinking, but you're timesing by 2. Yeah, everything's opposite of what you think. So you're not really timesing by 2. You're cutting it in half. This is horizontal on the inside. That's on the outside. So I hope you know the opposite. Horizontal's on the inside, vertical, vertical on the outside. And this seems like it would be 4 times as big, and it is, because you can trust the stuff on the outside. All right, so what if it isn't about graphing? What if it's just write me an equation? I can write you an equation, y equals x squared. But wait, that has been vertically shrunk by a factor of 1/4. Everybody change this so that it does what they said. Make the equation a little different so it does what they said. Okay, you should have put a 1/4 right in front. Why? Why in front? Why not inside with the x? Why not put a parenthesis around the x and put it inside? Because it's a vertical. And verticals are on the outside, All right, this next one, y equals absolute value of x. And I have a theory that since we just did outside, yep, look at that. They're horizontally, that's horizontals on the inside, right? Going to put something inside there. A shrink factor of 5. And I know some of you are like, oh, easy, put a 5 there. Nah. What's wrong with that? Well, you can't trust this stuff. You don't put a 5 in there. The x is still in there, but you don't put a 5 in there. You put a 1/5 in there. I'm guessing a few of you caught that. All right. I think these pictures are very nicely done, so we should talk about them briefly. If this is the parent function, do you get how this has been stretched? Does it look like they messed with it horizontally or vertically? Like if they grabbed, and again, I'm going to put like 3, 4 little fingers on the top and a thumb on the bottom. Imagine that's somebody's hand, and they're grabbing it. Do you feel like they grabbed and dragged to the right, or do you feel like they grabbed and dragged up? I feel like it was up. And so if the parent function was the square root of x, would you have known that? Hope so. The transformed one would be what? I'll pause for a sec while you give that one a try. Okay, the new one will be the square root of x, except it's, to me, I can tell it's been dragged up. How far up? Well, if I look at this point and I look at this point, think about this 2 and this 10. Doesn't that kind of indicate a relationship of times 5? Is it as simple as just putting a 5 in front? Let me think it through. So this is a vertical on the outside. Did this actually get stretched vertically? Yeah. Why isn't the 4 changing? The 4 and the 4, well, because the x's are staying the same. It's just the y's that are changing. See, y equals, and then it's 5 times as big as it was. I think I've got it. This 15 and this 3, to me that means times 5 again. So yay, I think I got it right here. Okay. We're almost done here, ladies and gentlemen. I'd like you to take this function, and if we call it f of x, that's kind of dumb because we know what this function is. We can say, instead of just using the generic f of x, we can say it's y equals, yes, y is the same as f of x, but equals absolute value of x. That's the parent function. Then everybody try to think about what would be the equation of this one. Hint, it has to do with the absolute value of x, but is not quite that simple. I'm going to move this x kind of to the middle, give myself room. Try to think through what would need to go where to make this happen. Well, what needs to happen is I need to look at my 1, 1, this point right here, and see it's changed to a 4, 1. 1, 1 turned into 4, 1. And 2, 2 turned into 8, 2. Looks to me like the x's are all getting multiplied by 4. Let's see if that's still the case here. Yup, times by 4. Yup, times by 4. But then why do I not put a 4 right in here? My x's are getting times by 4. I hope you're thinking to yourself, because it's on the inside. So you do the opposite of what you would think. You put a 1/4 on the inside. Now, if you were like, prove it, server, I think it's the other way around. Here's how I could prove it. I could take this point and I could say, if I put in an 8, would y really equal 2? Because, I mean, that's what it says it equals. So if I put in an 8, I get 8 divided by 4, or 1/4 times 8, and that would be 2, and then its absolute value of 2, which is 2. Worked out. So I know by checking it with a point there, that's the right way to do it. Okay. This is like a hard R3 test question. And the test, of course, is not today, and it's not even the next time we meet. It'll be the time after that, because the next time we meet will be a big review day. But I'd like to see if you can get a few points just to keep the teacher from losing their mind on all the different possibilities. Because if kids can put in anything, there'll be so many things they'd put in. I'd like you to put in things that make this get close to 0. Because, if you make the inside 0, like the whole thing kind of is really easy and nice. So I'd like you to put in -3. I'd like you to put in -2. I'd like you to put in -1. And let's just put in one more. Let's put in -4. Everybody try those points. To me, these are kind of irrelevant because they're not going to give you the parent points. So you put in these and let's see what y values you get. And then please sketch it. Pausing. All right, so I'm hoping put a -3 here, and you got a 0 squared is 0 times 2 is still 0. And then I put in a -2. -2 plus 3 is 1. 1 squared is 1 times 2 is 2. And then let's put in -1. So put in -1. -1 plus 3 is 2. 2 squared is 4 times 2 is 8. And last but not least, -4. -4 plus 3 is -1. Squared is 1 times 2 is 2. So now I'm going to graph these points. -3, 0. Next, -2, 2. Next, -1, 8. I missed there. Okay, and then -4, 2. I'm feeling like I did something wrong. Double checking. Oh, it's just that this point is kind of graphed a little wonky. So, because it should have more symmetry than that. There we go. And if I were going to ask for one more point, I'd probably put in -5 because I want to get another point over here. And I bet you it would turn out to be that point so that I have some symmetry. And -5, let's check. If I put a -5 in, this is really 2. 2 squared is 4 times 2 is 8. Yes, -5, 8 is that point right there. And now let's just connect these all with a nice red line. And there we go. That's a typical difficult test question on stretching, shrinking. They could have also asked you which way did it move. Look how it moved left 3. See how it's actually moved over to the left 3? And then look how it's got a vertical stretch of 2. That means it's basically narrower than the classic parabola, which would have been more like this. But it's been grabbed and dragged upwards. So I'm exaggerating on this, but that does have a vertical stretch factor 2 built into it. So, all right, I'm hoping you're feeling better about this stuff. And now you will find your homework and your teacher will explain which parts you should do. Basically, we have a little Schoology quiz that I think you already did before we started this lesson. And yeah, there's just 3 problems on that worksheet, which is called Day 2 Stretch and Shrink Functions. So Day 2 stretching and shrinking functions are just 3 of these difficult graphing problems on it. Rise to it. You can do this. If you're having trouble, ask for help. And the main thing is find points by putting numbers into the function. That's the key. That's all I got for you for today. Next time we meet, it'll be a review. And then after that, it'll be the test.